Our first assignment consisted of research where the class was divided into two separate groups, one representing cons of drones and one representing pros of drones. And in this assignment, we were able to learn about the different impacts that drones have on our society today. As you can see, different groups came up with very creative and detailed posters. Through this, we were able to participate in a class discussion, communicating whether the pros of drones outweighed the cons or vice versa. Our next assignment was regarding the laws and regulations of drones. And after much research, we used the website Know Before You Fly to put our knowledge to test. The significance of this was that we were able to learn even more about how important it is to know the rules and regulations regarding drones, and this would help us stay out of trouble if we were one day to fly our own drones. Then we were introduced to the engineering design process, which I used throughout the progression of our next assignment, which was to design our own drone frame. The first aspect of this process is to ask, in other words, identify the problem, which at hand was to create our own designs. The next two aspects of the process are imagine and plan, but first I had to get accustomed with SketchUp, the software that I would use to create my frame. Which brings me to our next assignment, which was to create geometric shapes such as a sphere, a cone, a cylinder, a hexagonal prism, a rectangular prism, and a triangular prism in SketchUp. And here we are looking at my first frame design, and as you can tell, there wasn't much planning due to its asymmetric shape, miscalculated dimensions, and simplicity. However, you can see that more planning was incorporated in my second design, as the shape is symmetrical, the dimensions are much better, and is more pleasing to the eye. In my third design, even more planning is evident. However, I left out many important details that are significant to the frame. For instance, how will the rubber tubes that hold the motors be attached to the drone, or whether the arms were long enough that the propellers wouldn't collide, or most importantly, will the weight of my frame be enough to carry the weight of all the different parts that will be attached to it. To ensure that our drone frames were the ideal weight, which is 4 grams, we were given an assignment in our group to develop a generic formula that would help us determine the weight of our frames. My group and I came up with weight equals volume times density. To apply this to our individual designs, we distinguished the recognizable shapes that together created our design, and by doing so, we were able to find the volume of our frames. Once the volume was acquired, the easier part was to simply multiply that by the density of the base material, for which we used the value 9.48 centimeters cubed. And thus, I was finally able to plan the perfect frame. To skip the gory details, this is my final frame with all the right measurements, so let's get to printing. This is my printed frame, and although all the measurements were right, I will still have to make modifications to the height so that it's stronger and not as bendable. This assignment was to create our unique and personal soldering designs while also getting familiar with the soldering machine. One end goal that I had for this class was to be able to fly a real drone by the end of it. And being able to learn to do so first on the flight simulator helped me gather some skills, so when I did fly a real drone, I wasn't putting myself or anyone else in danger. And finally, I was ready to fly after passing my flying test.